right, this is 2010 Form B, AB free response 2, and we are doing AP review. The function g is defined for all x values greater than 0 with g of 1 equals 2. G prime is given as sine of the quantity x plus a 1 over x. And then they do the derivative for you and give you g double prime, which I'm not going to read out loud to you because you have it in front of you. I went ahead and put my g prime in as my y1, which I made a note, and my g double prime in as my y2, which I made as a note because I figure I'm going to have to use them. So I may not want both of them on the whole time, but as soon as I'm handed these on a calculator section, it makes sense to put them in. All right, part A. Find all values of x in the interval from 0.12 to 1 inclusive at which g has a horizontal tangent line. Okay, so our first job here, right, so we're on the interval from 0.12 to 1, right, and we want g to have a horizontal tangent line, right, so horizontal tangent line. So that's what they're asking me for, right? So I need to translate what that means by definition and then figure out how I can let my calculator find that for me, but I have to do the actual thinking and the calculator will do the number crunching. So that's the ask, is when does g have a horizontal tangent line? Well, I know that by definition, that's not how I abbreviate definition. Okay, by definition, g having a horizontal tangent line means that g prime of x is 0. So if I were to link that to what I see in my calculator, I'm looking for where y1 is 0. So what I'm going to do is I'm going to go into my calculator and do a couple things. The first thing I'm going to do is turn off my y2 because I don't want to know about y2. I only want to know about y1. I didn't clear it because I'm probably going to need to use it later, but I turned it off, right? And the second thing I'm going to do is go to my window, and I've actually already done this. I'm going to change my window to include 0.12 to 1 in the x direction, because that's all I care about, right? 0.12 to 1. And then I'm going to go ahead and graph. So now, anywhere that this function crosses the axis, those are the things, like anywhere this function touches the x-axis, those are the things I want to find. So now I can second calc 0, right? So I'm going to do second calc 0, and again, the AP doesn't need to see that, that math notation that you're using, but you should know how to do that. So second calc 0. I always start with the one that's the farthest to the left. You don't have to do this. It's just my preference. It's the way that I know personally that I didn't accidentally skip something. So I'm just going to go all the way over, even though it's a little bit out of my way. I'm going to hit enter because I'm to the left of that. I'm going to cross the x-axis and be to the right. And then I'm going to hit enter again. And I'm going to get that x is approximately 0.163. And you can write the whole thing out if you want, just in case you're going to need it. I don't think they need me to do anything other than give those values, but I'm going to write the whole thing out. So that's the first one. And then I'm going to do second calc 0 again, and I'm going to work my way over to this second one. And there should only be the two of them. And I get that the other x value is 0.359433. So when I go to give my answer for part A, since they don't want me to do anything else with them, I'm going to have x is approximately 0.163 and 0.359. So those are my two answers. Yeah, that's the deal. All right. Oh, and you do need to communicate this information, right? This piece of information is going to be worth a point on that AP in addition to the answer. So please make sure whatever they ask you, translate that to the definition. And if applicable in this problem, also write how that's related to what you can currently see. On a non-calculator question, it might be a given graph or something. Here, I just need to find where my g prime of x is equal to 0. On what subintervals, on that open window from 0.12 to 1, if any, is the graph of g concave down? Justify your answer. So there's actually two ways that you can do this with the information that you're given, and I'm going to walk you through both. You shouldn't do both on the AP, but I just want to point out there's an easier way in this situation because they gave us g double prime, but there's another way you could do it if you had only been given g prime. So for part B, the thing they're asking, right, is on this window, the open window from 0.12 to 1, when is g concave down, right? So that's the question we were asked. We then need to translate that to the definition, right? And I'm going to show you the two ways that you can go from that definition to get the answer. The definition of g being concave down is that g double prime of x is less than 0. And you need to communicate this because it matters. Now, from here, you have two options, okay? So the easier option in this case is because you have g double prime and it's already in as your y2, you could just put your y2 in and see when it is below the x-axis. Right? That's the easier option here. You could use second calc 0 and see when it's below the option. But your other option, okay, the other option that would be really useful if g prime was not given, right, is you could recognize that it's really when the slope of g prime, because slope is like derivative, so the derivative of g prime is negative. So it would be when the slope of the thing you put in your y1 is negative, and what that visually looks like is y1 is decreasing. So you could do this in one of two ways. You could either do the much easier option of putting your y2 in your calculator and second calc 0 and finding when it's below the axis, or you could do it using this other option of looking at finding when y1 is decreasing. Now this one would involve, so the easier one involves using second calc 0, right? And this one is going to involve finding the maxes in mins, so second calc max or min for the y1, right? So second calc 0 for y2 or second calc max for y1. I would not suggest doing the second option in this case, but I just wanted to point out that if you hadn't been given g double prime, that would be a decent option. So I'm going to pick the easier option, right? I'm going to pick this option. So in order to do that, what I'm going to do is I'm going to go to my y equals, and I'm going to turn off y1 and turn on y2, right? So you turn them off and on. I re-highlighted y1. So y1's on because it's highlighted. If I go over it again and hit enter, I'll turn it off, right? Same thing with y2. I can make sure that that's highlighted, right, and then hit enter to turn it on. Now watch this graph carefully because it's deceptive. So I still have that same window from 0.12 to 1, but watch what happens. When I hit graph, there's very quickly a nearly vertical line that happens. So watch carefully. Okay, so there was a very quick vertical line, and then this comes up here. So what seems to be happening, if we look at our g double prime graph, is it seems to have come shooting down and then come back up and then do something like this. So it seems to me that the only possible candidates for when it's negative, right, when g double prime is negative, are here and maybe over here, depending on where this thing actually intersects 0. So I'm going to look for this first 0, the one that you could miss if you're not careful. So I'm going to do second calc 0, and I'm going to scroll all the way over here. And notice, I think that there's a 0 somewhere right after 0.12, like really, really small number, really close to 0.12, really close to the edge of my interval. So I'm just scrolling, holding down the left button to work my way back, okay? So now this is where we need to start paying attention. So notice that that my y is super negative. It's like a negative 24, and then it jumps up to being positive. That's actually above the axis. So left bound is above the axis. Right bound would be below the axis, way down at negative 24, even though I can't see it. And then I'm going to go back up to that 0.33 to guess. And sure enough, I get that this first 0, this really sneaky one right here, right, that I'm just going to call 0 letter A, right? I get that that A is when x is approximately 0.129, right? And then if I do it again to find this next 0, second calc 0, I'm going to work my way to the right a little bit until so see how that was super negative. You couldn't even see the cursor, and then it works its way up. Okay, so I'm still to the left. I cross the x-axis, and then I just hit enter again after I cross, and then I guess. So, and I get that the second 0 is at x is approximately 0.222 or 3, depending if you round or truncate. Now, the big question mark is there another 0 over here? Does this thing cross below the x-axis before it hits 1? So in order to do that, I'm gonna just trace, which I think is actually easier, right? So I'm just gonna trace over. I'm gonna hit trace, and then I'm just gonna work my way over, and I'm gonna see if, because I don't know if there's a 0, it's really hard to tell. So I'm just gonna work my way over. I see how I still have all positive y values, all positive, but they're definitely getting to be lower. They're closer to 0. All positive y values. Remember, my window only goes up to x is 1, so I'm just investigating to see if I get negative y values before x hits 1. Negative y values. I still don't have any negative y values. Still don't have them. Yep, so it turns out that that 0 is actually at x equals 1, right? And that's not in the interval because it was an open interval. So these are the only two zeros, so it turns out that this is all positive. So then my answer is the interval between this a to b. My answer is that g is concave down on the window from 0.129 to 0.222, or that could be a 3, depending on if you round or truncate. Okay, that's my answer. If you like parenthetical, like I do, that's great. If you don't, you could do it as inequality form like this, right? Either of those is fine. Okay, so that's B. Part C. Write an equation for the tangent line of the graph at x equals 0.3. Okay, so I need two things in order to find a tangent line. Right, so for the rest of math, forever and always, if you're asked to find the equation of a line, right, you need a point and you need a slope. So one, I need a point, and that's actually the harder one here. So that's going to be 0.3 comma g of 0.3. That's the part that's going to require a little bit more math because we have to figure out what g of 0.3 is. And the second thing I need is a slope, but I know that since it's the tangent line, my slope is just in this problem going to be g prime of 0.3, which I can plug in easily in my calculator. So the slope's going to be the easier part, okay? G prime of 0.3 is going to be easy. There's a couple different ways to do it. Honestly, you could either turn your y1 on and turn y2 off and then trace, which is fine. So if you did this and you hit, if you hit graph and then you trace, it's going to graph right now. That's my G prime, right? One option is to graph G prime, hit trace, and then type in 0.3, and it'll give you a value, right? So this is a negative 0.472, right? And that's great. The other way to deal with this is you could go to table set, second window, which is table set, and you could say, hey, I just want to start at 0.3 and see what happens. And then if you go to second table, sure enough, there's your y1 value that you want, okay? Same value. Notice that if you only have a couple places in the actual table, you can get all the places or a lot more places by going down, by scrolling over here and then looking at the bottom. So I've now got my slope. Great, I now need my other half of my point. So to find g of 0.3, I need to use this g of 1 is 2, and I need to use the first fundamental theorem of calculus. So the first fundamental theorem of calculus says that if you integrate from 0.3 to 1 of g prime of x dx, you're going to get g of 1, which is a quantity that I know, minus g of 0.3, which is a quantity that I want. Since I want to solve for g of 0.3, I'd probably add this guy over and subtract this guy over, right? So I'm going to get that g of 0.3 is g of 1 minus the integral from 0.3 to 1. Sorry, that's a very sloppy 0.3. 0.3 to 1 of g prime of x dx. So I need to communicate this information, but then I'm going to use my calculator to find it. So this is a 2 plus function integrate y1 with respect to x from 0.3 to 1. Oh, sorry, 2 minus, my bad. There's a minus sign. So if I quit out of this, right, that's a 2 plus math, see, I did it again. It's a minus. Come on, Hogan. 2 minus math 9. That's my function integrate. I go to vars. I go over to yvars. I pick function y1 with respect to x from 0.3 to 1, right? And I hit enter, and I get that that's a 1.546. So once I know that this is a 1.546, well, now I have my point, right? This is a 1.546, and I have my slope, which was the negative 0.472. So all I have to do is write my answer in point slope. So my answer is y minus the y value, which is the 1.546, equals m, which was the negative 0.472, x minus the x value, which is 0.3. And that answer is totally fine. If you really like to solve for y, please don't combine like terms. Just add the 1.546 over to the other side. So you get y equals negative 0.472 times the quantity x minus the 0.3, all plus a 1.546 on the other side. So that's also fine. Cool. Part D. Does the line tangent to the graph of g at 0.3 lie above or below the graph from 0 to 0.3, and say why? Cool. So this is about concavity. So part D, when you're asked if a tangent line is above or below a curve, it's 100% about concavity. If something is concave down, right, then its tangent line sits on top. And that would be true no matter where the tangent line was relative to this thing. If something's concave down, the tangent line sits on top. If something's concave up, the tangent line sits underneath, right? It doesn't matter where you draw the tangent line. If something's concave up, the tangent line sits underneath. So really what D is asking you is, what's the concavity of G on this window? So we've already established, if you look at part B, if you look at part B, the only time that G double prime of X was negative in the window leading up to 1, right? G double prime of X was less than 0 from that like 0.12 something something, 129 maybe to 0.223, right? So we know that that at x equals 0.3, g double prime of x is greater than 0. In fact, it's greater than 0 for that entire window. In fact, it's not just at x equals 0.3. It's actually we know that it's from 0.2 to 3, right? We actually know it's from 0.223 upward until at least 1, right? So if g double prime is positive, we're looking at this situation, right? So g is concave up, which means that the tangent line sits below the curve, right? And again, you don't have to have this memorized. You just need to be able to draw a concave up and concave down curve and look and see what it looks like, right? Where would the tangent line sit? So the answer is below, and it was